Now recording. So, how's everybody doing today? Good. How's your weekend?
Short.
Short? Yeah, I know, right? So, I noticed I only got like 26 submissions for the assignment. So I think that was correct. Let me see for a moment. 24 submissions. So if your assignment is still outstanding, please get it in ASAP. Because remember, there is a 20% deduction per diem for late assignments. So if you're gonna not submit it today, you're gonna submit it tomorrow, or basically you're not gonna pass the assignment. And even at like, a 40% deduction, that's pretty hefty. So please get your assignments in, that's what I'm trying to say. Okay? So, speaking of assignments, let's talk about assignment 2. This is one of those classes. We've got an assignment just about every week. So, don't fall behind. Assignment 2, Bash shell scripting. I almost said Bash scripting, which would have been hilarious. So, Bash scripting is the primary topic that we are going to be talking about today. We will also see if we can get through to the week 3 materials, see how much of it we get through, hopefully all of it. That material is on editors and how to use them properly, so that should be useful. So, for assignment 2, once again, you will be creating your demonstration video where you demonstrate the following stuff using the Linux Mint image and the VirtualBox. Demonstration video should be under 10 minutes. Yes. You will need to submit the code for task 2 and 3 in a zip file. See instructions below. I want to see the code. Task 1, diff. You have to download difffiles.zip and unzip the package 1 and package 2 JSON files. By the way, if there's anybody in this program whose name is Jason, I deeply apologize. But this is the discipline you unwittingly chose. So, open the Bash shell. If necessary, change directories to where package 1 JSON and package 2 JSON are located. Use diff to find the differences between the two files and explain the output that diff provides. What exactly is it telling us the differences are? How are the files different? And more importantly, how does diff tell us these files are different? That is, what do the numbers, letters, and symbols mean? It may be helpful to open up the files in Visual Studio Code as part of your explanation. Visual Studio Code. My goodness. If you're going to open a file in a bash prompt, what do you open a file for reading? What's the command? Come on, folks. How can you see a file from a command prompt? That's it. Cat. So, Visual Studio. Just to see a file. Talk about taking a sledgehammer to a pin. Good grief. Task number 2. Multi-copy script. Create your script multicopy.sh before starting to record your video. Please have the script done before you start recording. The video is not a video of you writing the script. Okay? It's a video of you using the script. So, the script should work as follows. If you put multicopy.sh into bash, giving it example.txt, copy1, copy2, and copy3.txt, it should create copies of the file, example.txt, called copy1, copy2, and copy3. You can assume that the script will always be given the correct number of command line arguments, You can assume that the file to be copied already exists, and that makes things much, much simpler. Well, it saves you a few if statements anyways. So, and then this is the description of how you should demonstrate it in your video. Any questions about the first two? Hopefully, your thoughts at this point should be, well, I know how to copy files. I don't know how this whole scripting it stuff is supposed to work, but I can perform the operation the script is calling for. That should be your level right now. Okay? Fortunately, today is the day we're going to talk about how to do all of that stuff. Okay? Sound good? Don't worry, it's really easy. It's really, really, really easy. Don't worry about it. Okay? Particularly for that one, because I don't think that one even calls for any logic. So, task 3, multi-concatenate. Before performing this task, create the bash shell script called multicat.sh. We had cat, and now we have multicat. The script should work as follows. Multicat, file 1, file 2, file 3, file 4, file 5 should concatenate the contents of file 1, file 2, and any of the other files provided via additional command line arguments represented using ... So the big difference between the previous and this one, the previous one had a fixed number of parameters, and you can assume that it's always used according to that. With this one, you have a hypothetically infinite number of parameters, although I wouldn't be able to type all of those. You can assume multicat might be tried on 1, 2, 5, even 10 files. Keep in mind that when, now that we know a bit about piping, the input to this script might not be something that somebody typed out. It could be the output of a program like ls. That is to say, if you piped ls into this command, you would concatenate every file in the directory that ls was showing. Right? Make sense? So, you can assume there are at least 2 command line arguments. The concatenated contents should be written to the file name of whatever the environment variable cat file is set to. So if cat file is set to cat.txt, the concatenated contents of the file should be written to cat.txt. If the environment variable cat file does not exist or is set to the empty string, the script should output to the terminal, environment variable cat file must be set to a file name. Hint, it is probably a good idea to use a temporary file to help solve this problem. You can call it whatever you like, and you can assume that it does not already exist in the directory. So, basically, Cole's Notes version. The script expects an environment variable called cat file to exist. This is something that you will have to set when you do your demonstration, right? Step 5, set the cat file. Step 3 is show what happens if it's not set. Step 5 is set it, and then step 6 is to run. Does that make sense? So basically you're writing a bash script that borks on an error if it doesn't have the right environment variable set. Otherwise, it concatenates the files. Does this make sense? All good? We will go over specific techniques. This one requires a bit more programmy stuff. Hopefully, given that this is 4th semester, everybody can instantly recognize that this program calls for a loop, right? So we will go over doing loops. In particular, we will also go over how to take arguments, and an unbounded number of arguments. So, good. Any questions? Due for Sunday then. So, if you don't have your Linux Mint image up and running, let's take a moment to do that presently. Please get Mint, let's get minty fresh. There we go, importing appliance. Our first topic for today is configuration files. This one's a bit of a shorter one. Still very important though. So, config files. Very good. So, if you recall, when we were talking about environment variables, one of the types of files that we discussed during that lesson was a .env file. What env files essentially are doing, they are providing values for environment variables, collecting those values into a file, so that those values can be reinstantiated when needed. For example, when you're starting a new shell session, all of your variables have to be reset to particular values. Maybe there's when the computer is booting as well, obviously your environment variables will have to be set to particular values. These values don't just magically appear out of thin air, they're stored in .env files, right? So, that is a useful concept, right? It is so useful that many, many different types of programs use that concept. This is the concept of a configuration file, or config. Configuration files are used to configure the parameters and initial settings of an application. Often called config files, because configuration, 5 syllables. Config, 2 syllables. Therefore, better for programmers. Programmers love as few symbols and characters and syllables as is possible. Config files are read by applications, typically before execution, though sometimes periodically during execution. I'll bring in a video games analogy, all right? Pick your favorite video game, right? If you start a new game, you can imagine certain stuff has to be started. You have to set certain values for the game to be started. Let's say you exit to menu and then start a new game again. You'd be rerunning that same initial config for the game, but the program hasn't actually ended, right? There you go. So, config files don't have a particular standard format, but there are multiple standards. So, this is another one of these kind of situations where, different people do different things in different ways, but there are generally accepted forms that make things easy. Normally, when there's a parser that's been written for a particular standard. So, typically config files are plain text, but GUI might be used to edit config files which are not. For us, I'd say probably a good 90% of the time, when you're modifying config files, you're jumping into big, long, they're usually quite long plain text files. Right? Oh man. You want to hear a fun story about config files? I have a fun story. All right. So my wife, she loves this game called Zoo Tycoon. You guys, anybody ever play Zoo Tycoon? Yeah, there we go. So, one of the things that you may find annoying as a serious player of Zoo Tycoon is like the number of simultaneous NPCs that you can have walking around your park at one time is capped at about 600. Now, if you'd played Roller Coaster Tycoon, or particularly Roller Coaster Tycoon 2, you know that you can get like well over 1,000. So like, what's the deal? What's the deal, Microsoft? Turns out that value's in a configuration file. And you can just go into your copy of Zoo Tycoon, bump up the number of people who could be in your park, right? And then play your game. And because it's a Microsoft product, it crashes when you do that about 50% of the time. But the other 50% of the time it doesn't. So like, what's going on? I don't know, you know? But it's interesting, you know? Dwarf Fortress has the same thing. You can like up the population cap on the dwarves in your fortress using the initialization files. Anyway, everything's important because of its application to video games. Common configuration file extensions include .cfg, CNF, conf, or CF, particularly .ini. Those of you who were with us in PHP, when I do PHP, sometimes like I pull up the php.ini that exists inside of XAMPP to show you a few things. But so you know, the PHP implementation in Apache servers uses .ini. This is there's a rough standard for ini. This is like one of the better supported ones, right? JSON, I'm sure everybody knows JSON. .env, we talked about already. XML, you guys know what XML is? You should, by this time I think. Yeah? Can anybody tell me what XML stands for? Without looking it up?
Extensible markup language.
Extensible markup language, yes, very good. HTML is a subset of XML. So the difference between XML and HTML, with XML, you get to determine the elements. You get to determine the elements and you can assign, like, basically if you took everywhere that you have like a specific string that means a specific thing in HTML, and you said, I can just put whatever I want there, that's now XML, right? But anyway, I digress. And how about YAML? How many people have heard of YAML before? So what's YAML for?
I don't know, but I've used it.
Okay, yeah?
I used it for Docker Compose configuration files.
Yes. So YAML follows the same format as JSON. JSON actually, in certain circumstances, can be read by the YAML parser. JSON can be parsed as YAML in some cases. But YAML is, so this is the analogy, right? You know how Java syntax feels? You know how Python feels in comparison to Java, right? It's like I take all the curly braces out, indentation matters now, right? I take out the semicolons because they're useless. YAML is basically the Python treatment of JSON. Does that make sense? So it's like, it's taken out all of the stuff that it considers, you know, not useful syntax, and it's replaced it mostly with spaces. But YAML we'll talk about today, some of the particularities. But it's used for basically the same thing that JSON is used for. More modern things, like, for example, Docker, are now using YAML as opposed to JSON for configuration files because it's more human readable. But that doesn't mean you won't still see plenty of JSON, you absolutely will. But basically when you have a config file where it's like, yeah, okay, a human is supposed to read this, it'll often be in YAML these days. Does that make sense? Good. Wonderful. Oh, but for these top ones, it's the Wild West, man. However the program expects it. There's no real fixed format for them. So modify at your peril, basically. Know what you're doing and back everything up and expect something to break if you mess with it too much. Swapping an integer for another integer you should get away with, but be careful. So, languages often have libraries and packages which allow us to easily read config files. Certainly any program that uses a config file will have some module which reads the file, right? Python has a config parser package which is designed to read .ini files, for example. So Python can just, load up an .ini file reasonably easily. The same way that Python has, it's a good language for parsing files. There's a lot of parsers that are easily accessible in Python. So this is what a .ini file looks like. All right, let's dissect it. Number one, and this is strange, but there's a reason for it. Lines with a comment, or comment lines start with a semicolon. So basically, everything past a semicolon is assumed to be a comment, right? Which actually means, in some iterations, you can put a semicolon at the end of a line, and then the rest of the line is a comment, right? This is a standard that, believe it or not, has been borrowed from, of all things, assembly languages. But yeah, section headings are given in square braces, and then you just have a sequence of key value pairs after that. So if you want to modify it, you just modify the value. You'll notice there are no quotes. Make sense? Except for there. Quotes or no quotes, depends on, I guess, what the program is expecting. So, ini files are widely used in Unix-like systems. Make sense? Good. One good reason to use quotes would be if the thing that you're including here, is supposed to contain quotes, right? Because then you can escape them within a string. So, XML files. XML is the extensible markup language. HTML-like, actually, to say it's HTML-like is to say almost nothing. XML is a superset of HTML. So every HTML file is valid XML, so long as it's valid HTML. Yes?
Do you know if XML or HTML existed first?
Oh, that's a good question. I would guess XML. I don't think it's chicken and egg. It's we had to invent the wheel before we created the cart kind of territory. Now, the motivation to create the wheel might have been to create the cart, but the wheel had to be made before the cart was.
I think it says HTML was first developed before the XML.
Oh, really?
Yeah. It says
What's your source there?
Developed in 1993, and the other one was developed in 1998.
When was XML invented? here. Okay, all right. Well, okay. So I'm gonna start splitting some pedantic hairs. All right. This might have been when the standard was written, but XML itself likely predates the standard. Right? That's, yeah, all right. Well, anyway, let's keep going. Right. So, similarly to HTML, we have tags opening and closing. Closing tag has the slash. I'm sure everybody's familiar with the structure. Once again, the big difference is you get to choose what these names are, unlike in HTML where those have fixed values that mean different things. You also have one tags. Yes. You can also give properties, right? The same way as in HTML. In HTML, again, you have a bunch of properties which have fixed values, but in XML, you can just decide what they should be, right? Similarly to, plunking key value pairs into a JSON. XML also picks up the hierarchical structure that we all know from HTML, and documents begin with a declaration plus a little bit of metadata about what the character set is and what version of XML you're using. So very similar to the doc type at the beginning of an HTML document, you have one that declares something as being XML right there. Sound good? Let's take a look. Here we go. So here's an example of a configuration file encoded in XML. Configuration block, email block, phone blocks, type home, type cell with different numbers. That's not my number, by the way. Nor is it Kevin Brown's number. You can assign multiple parameters, and this would be a self-closing tag. Enough said? Yeah, everybody, like you guys have been doing HTML for some time now, so yes.
Is there, you see how the phone, it's open tag, then the phone number, then the close tag. Is there a reason why they do that instead of saying like phone type equals home, and then like number equals something, and then do a self-closing rather than open the tag and then close the tag afterwards?
Well, because this is kind of like, this is a less proscribed environment than HTML, both of the methods you've described would be sufficient to send that information where it's going, so long as the receiving program knows where to find the information. Yeah, it just kind of depends on how you want to think about things semantically.
Okay.
Both of those work, right? Yeah, I would say like probably the distinction is like in the case of login, right? I'm not like, what would you say the string version of the login is, right? It like there isn't really one. A login is an event, not like it's like a verb and not a noun, if that makes sense.
Yeah.
Whereas a phone number, like, has a existence as a, like, if I say give me your phone number, you know what I'm talking about, right? When I say give me your login, you're like, well, that's not really good grammar, but what you want is my login credentials. And absolutely not, I never give my login credentials to anyone, for any reason. All right? Make sense?
Yeah.
Yeah, cool.
Actually, I got another follow-up.
Sure.
Sorry.
Yeah, no, of course.
Do you know if it would be possible to like open login, give no and not give ID or password, and then have like an ID tag and a password tag as like sub-tags within the body tag?
Oh, you totally could do that, yeah. Yeah, again, it's like, it's kind of like how much writing do you want to do, right? The only time you're really obligated to, like, not make everything an attribute is when, like, it's obvious that you want a hierarchy, like a hierarchical view, or this thing contains multiple of the same named thing,
Oh, okay.
right? Like, you can't have two attributes called email. You can only have one attribute called email. So if you want to contain multiple emails, they have to be sub-entities.
Okay.
Make sense?
Yeah.
Yeah. But yeah, it's very loosey-goosey.
Okay.
I may have mentioned this before, but did you guys know that Microsoft Office files are XML under the hood? Did you guys know that?
Like docx.
Yeah, so docx is particularly kind of funny. Basically, it's just XML that's been zipped. That's it. So if you take a Word document and you change the file extension to .zip, and you convince Microsoft to unzip it for you, there's like a bunch of stuff in there, but there's like mainly like an XML file. Yeah. JSON! So, I imagine all of you have used JSON before. He waggles his eyebrows as he says. JavaScript object notation. Fairly popular, you know. NPM, the Node package manager. What's Node? Node dot.
JS.
So what's the language? JavaScript. So you would expect Node to be using .json, right? Anything that's kind of integrally tied up with the JavaScript ecosystem is going to probably default to JSON, right? Widely used in web development. You know, like, you guys know that like over 80% of all internet traffic is API calls now? And you know that like in the majority of cases, what an API call means is I'm sending JSON back and forth, right? So JSON is used quite a bit in the web. I saw a joke once. It said, "That's not REST." It's like, well, it's only REST if it's developed in the REST region of France. Otherwise, it's just sparkling JSON. So there are no comments allowed in JSON. This is an example of JSON. I'm sure we've seen all of this before, right? Hierarchical org structure with arrays and objects, right? Everybody cool with JSON? All right, let's keep moving. YAML. So YAML is a recursive acronym for YAML ain't markup language. This is what it now currently stands for. What YAML originally stood for was yet another markup language. Programmers have interesting sense of humor. So YAML files begin with // There are no tab characters allowed in YAML files. So there's this like interesting little war that goes on in programmers. You have all of the programmers who use tab characters and all of the programmers who don't use tab characters. It's like, no tabs, spaces. It's like a lot of editors have it configured, or have a configuration option where if you hit tab, it doesn't actually insert a tab character, it inserts like a set number of spaces, right? This is, YAML actually like as a part of the YAML language, does not permit tab characters. So you can see where they stand in this fight, right? So, all right. New lines indicate the end of a field. Indentation with space denotes structure. Once again, very similar to Python. In Python, indentation indicates nestedness of a control structure. Here, it indicates the same kind of nestedness as a JSON, right? Are things inside of other things? So, before we get into that, I want to just show you what the example of an example YAML file looks like, right? 3 dashes at the top. So we have doe, a deer, a female deer, ray, a drop of golden sun. Key value pairs, except for this one, right? We have the colon, and then on the next line, this, that, and that. What do these look like? Like from a Word document or an email, what are those?
Like bullets?
Yeah, they're bullet points, right? So this is what we mean when we say it. It means to look like a, something a human would produce or read, right? This is actually an array. Translated into JSON, that is how YAML encodes an array of calling birds, including Huey, Dewey, Louie, and Fred. Right? Make sense? So far, so good? Okay. Here we go. So, unfortunately, key value pairs is a clunky term, and we can't quite decide what to call that. Pretty much every environment you're in will call it something slightly different. So key value pairs, PHP, we're talking associative arrays, which is even longer to say than key value pair, right? In JavaScript, we call those objects, which is bad and wrong because they're not objects, right? They're not objects until they have methods attached to them, preferably with a class defined. What do we call them in Java? Anybody know?
Functions.
No, data structure containing key value pairs in Java. What do we call that?
Dictionary?
That's Python.
Array.
Not an array,
Properties?
not properties.
What's the question?
Collection?
It's a type of collection.
List?
So, no, you get close though. If we have a list of key value pairs, similar to an associative array in PHP, and we want that in Java, what kind of object do we create?
Appsettings.json?
And it's not an array list, what did you say?
Appsettings.json?
Nope. It's a hash map.
Oh.
That's what they call it in Java, is a hash map. I'm not surprised you didn't get it though. Here, that concept is just simply called a map, which is actually not a bad term for it because what it really is describing in terms of mathematics and set theory, we've got one set, we've got another set. When you want to relate the elements of one set to another set in formal mathematics, that's called a mapping. So a map is like a particular mapping. It makes more sense. Map is a good term for it. Good job, YAML. But it's just a series of key value pairs. If you encode it in JSON, it looks like this. Oh, another really nice thing about YAML. You see the quotes, right? The quotes do not have to exist. The quotes are optional. As with quotes in all cases, if the string contains control characters for the language, put it in quotes. Otherwise, you can sometimes get away with it.
Can you escape maybe with backslash?
Yeah, you can escape quotes within the string with backslash, absolutely. Yeah. Like if you want the quote to be literally in the string. Yeah. Most of the time, you don't need that, but yes. So, yes, good. So, just a bunch of key value pairs hanging out. That corresponds to a JSON object. Would it be helpful if I took that and I wrote it out as JSON? Would that help? No? You guys get it? Am I beating a dead horse? Okay, I'm beating a dead horse. Okay. Anything else interesting to say? Yes. Multi-line strings. Here's one that's interesting. If you include the vertical bar character, that means as long as you're indented over, this is a multi-line string. Saves you the trouble of having to insert new line characters into strings. Alright? Also, quite readable. That's a limerick. So, we can also use arrow, which will fold the multi-line string and replace new line characters with the space character. So, the difference here, if you want to preserve new line characters, use vertical bar. If you don't, and you want them replaced with spaces, wrapped text will be folded into a single paragraph. Blank lines denote paragraph breaks. Make sense? This is actually a much more useful thing than you might think. Have you ever had that thing where there's this traditional problem in plain text where a lot of the time the editor that you're using won't word wrap by default, and a lot of people don't turn word wrap on when it becomes a problem, right? So a thing a lot of people will do is just when they reach the end of their terminal, they press enter and start on the next line with the line, right? Which is fine until you try to read that file in an editor with a different width, right? And then it's I've only got it at half the screen, or it's getting partially cut off, and then remapping and realigning all of your text to the new editor is just, we've all been there, right? Yeah, it's just a pain in the butt. So that's a way around it. Make sense? Any questions? All right. Thus concludes configuration files. Any questions about configuration files? Okay, sounds good. Now we get to do the fun stuff. Ooh. Oh yeah. God put me in this college to teach this slide deck. I'll try to do it justice. I know, poor, humble programmer such as I am, there is no way that I could compare favorably to the awesome immensity of the subject that we're about to discuss. But I will do my best to attempt it. Hopefully we'll all find my attempt satisfactory. Please understand that bash scripting is an extremely deep rabbit hole to fall down. We are only covering the bare essentials. See, the thing about bash scripting, which is interesting, is like you've got open source software, and then you've got open source software, right? Literally anybody who wants to can write a program, and if it's useful, it'll get picked up and even integrated into the language that is shell scripting itself, right? You get some really like funny like character expansions that are like really, really hyper compact and do very specific things, and it's impossible to remember them because like they're very, 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 very specific. So this is another area where it's like keep your desk reference handy, right? But fortunately, shell scripting is fairly easy to break into because you need to understand only a couple of things in order to start shell scripting, right? The first thing you need to understand, we are taking lines of code that we know from other languages, we are mostly throwing them out, and we are replacing them with bash commands, right? The operational unit of thought in a shell script is an individual bash command. Shell scripts, the purpose of them is to run a sequence of commands with, period. The purpose of a shell script is to run a sequence of commands. Asterisk, that sequence can get very complicated, depending on the circumstances. But that's all it's doing, right? The bash script, which I think I've already done one or two in class, the simplest bash script that you can do is just command, another command, another command, write a script, executes these three commands. Right? Makes sense? So, okay. So, repetitive tasks. I've heard it said sometimes that one of the greatest assets of any good engineer is their laziness. Right? We don't like repetitive tasks. We particularly don't like error-prone repetitive tasks. We are programmers. We program. We need to get the computer to do the thing so that we don't have to do the thing. That's our whole purpose. So, often when you're doing tasks in a shell, you're doing things repeatedly. It's like, oh, every single time I come into work, I have to do this, I have to do that, I have to fetch from the Git repository, make sure I've got latest changes, yada, yada, yada. There's like a list of things you have to do. Well, what if, my friends, you wrote a shell script that did all of your routine startup tasks and then called it from your login script? You can do that. And then every time you log into your computer, it fetches the latest changes from your Git repo. Right? Now, would you run into technical issues attempting to get that working? Possibly. See, this is another thing, right? Do you have permissions to do that, right? But you can certainly, if you can conceptualize it, it can be done. It's just a matter of how much work it is to get it working, right? So, another good example, carrying out tests. Maybe there's a suite of standard tests that you run against your software every time it's been, it's been a week, oh, I'm gonna run my tests, The tests themselves can be scripted, right? Testing is a very arduous thing. It's like, you don't want to do that by hand, if you can help it. Analyzing logs. Many programs generate log data, and log data is often huge. Sometimes you want to have a little script that scans through your log data looking for particular patterns because those indicate particular problems that you know how to solve that are recurring, that can't be fixed because, I don't know, the person you work with who's in charge of fixing it just went on vacation for like 6 months or something, I don't know. Perhaps we wish to run certain programs in response to log file contents. Ooh, here's an idea. Maybe a particular type of error occurs in the log file. Maybe you could train the computer to detect when the server's being hacked and shut the server down when it detects that it's being hacked. That sounds like a useful thing to do, right? Shell scripts! Shell scripts are the way. Shell scripts are the path. So, programs run by the command line interpreter. So it's literally this. You take a bunch of commands, you put them in a file, you tell the interpreter, run these commands, and it does it. That's it. Very simple in concept. Now, the layer on top of that is that you have loops, you have if statements, and you have variables. Shell scripts are, like, bash scripting is a programming language in the proper sense, right? It has everything that a programming language does. What it often lacks is those very nice abstraction mechanisms that we have from Java. Bash scripting is not an object-oriented language. It's a procedural language. It's closer to programming in C than programming in Java, C++, C#. Right? So, when we write bash scripts, we can actually write the script for any of the shells which we have installed on our system, but bash is the one that's most commonly used. That's the one that you should use, right? There's I've only recently seen the sh shell pop back up, and it is in the context of a Docker container, right? Like when you have a little tiny little miniaturized version of Linux running inside of a container, bash is like a lot, so it's like whatever wasn't necessary, we threw it out. And so all you have is a little program called sh, which is like a very old stripped down version of bash. And that's, that runs commands for you, but you don't have a lot of the bash programs that you normally have available, right? But you can write scripts for that too. You just have to target the right interpreter, right? So, one popular application of shell scripts is the setup and installation of programs. Most of the time, when you install a program on Linux, that's exactly what you're doing. Unless it's, anytime you're installing a program that you're not installing using apt or a package manager, you're kind of in dangerous territory. But it is absolutely possible to download the source code for a application. You look in the directory, normally there's a file that says readme. The readme says, this is the installation script. Go run the installation script. And you run the installation script and it installs. Compiles, installs, all of that, right? So the script is a way of packaging the software with its means of installation, right? Does that make sense? Because trust me, you don't want to have to compile someone else's code without any assistance. It's not a good plan. If it's anything more complicated than a school assignment, it's not a good plan. Shell scripts execute slower than compiled programs, but have the advantage of direct shell interface using regular shell commands. So, it's not a replacement for C, right? It's not a replacement for a programming language. If you need something done quickly, a proper programming language is what you should be using, but you know, they can, the advantage of like direct shell access is like, it's huge, it's fantastic, it's wonderful. Personally, for like the last 2 years or so, basically the only language I've been doing any serious programming work in myself has been Bash. So, yeah.
Why are shell scripts slower than compiled languages?
Well, you have to understand that these slides will be talking about compiled languages rather than interpreted languages. Although it probably Python outperforms Bash, I wouldn't be surprised. So, like there's a slowdown anytime you bring an interpreter in, right? Versus, right, like, it's important not to confuse Bash with the programs Bash is running, right? Like all of the programs that we use in Bash, like CP and LS and all of these things, these are C programs, right? Written, compiled C programs,
Oh, okay.
right? Therefore, the execution of something like LS, very fast. But the thing that binds them all together is not as fast, because it has to be interpreted, right? And also, like, you're basically saying, how much overhead is there in running the command prompt, right? That's where the slowdown is coming.
Okay.
Does that make sense?
A little bit.
Yeah. Just think about it this way, right? Your command line interface is a program. That program has overhead, right? Just running a straight C program doesn't have that same overhead. So C is faster, right? Like if you could take a shell script, write a C program that did the exact same work, that C program would be faster. Does that make sense?
Okay, yeah, it does. Thank you very much.
Cool. All right. So, our old friends XKCD. So, talking about automation. I spend a lot of time on this task and I should write a program to automate it. This is what you think will happen, right? You have your work, you write your program, and then afterwards, automation takes over, and you have way more free time. Satirically, what actually happens, you work, you're writing your code, you think you're done, oh, debugging, there you go. Okay, we're done debugging. Wait, I did the whole thing wrong. Ongoing development gradually consumes your life, and you have no time for your original task anymore. This is not completely true, though it is true in some cases. You have to be a little bit careful. I showed you guys that graph of like, is it worth it to automate it, right? Yeah. Understand that like there is an actual like practical cutoff. Am I saving more time than I'm spending on this? Right? Now, I would argue that everyone in this room should not worry about that for the time being, unless this class is significantly impacting your grades on other classes, all right? If you are, like, you have to factor in that this is not just like this is a little bit simplistic because like the outcome is only the amount of time you spend on your task. You have to think of this as like, this is also time I'm dedicating to Bash scripting and becoming better at Bash scripting, right? The more of these you've attempted, the more likely you'll be able to do this. And, you know, when I was reviewing these slides in preparation for this lesson, it popped into my head to say something like, Well, this is good programmer, this is bad programmer, right? A good programmer hits this every time. A bad programmer ends up in development hell for even simple automations, right? But like, you know, it's like sometimes you try something and it just doesn't work, you know? Sometimes, like, it's also a matter of like, how long are you going to have to repeat this task for? You know? Like a good example, one of the things that I've done, right, is I wrote in Bash scripting a grading assistance tool that I use on, like I originally developed it for JavaScript because I got real annoyed with like downloading the files from Canvas, right? And then I taught server side and it's like, what, like 8 files? I have to download 8 files. And it's like, whoa, we do bulk submissions. But except, you know, I said that in a stupid voice, but I should really say that in a sinister voice. Well, you could always use bulk submissions. Because the bulk submission tool is stupid. Because, like, it gives you every file everybody has submitted dumped into the same zip file, prepended with, like, your last name and your first name with no space characters, all concatenated together with a unique string. It's like, that's not useful. You've mangled the file names. So what did this script start off as? It started off as, okay, I have my list of students. I'm going to take the file out of the big submission zip file thing. I'm going to pull only the files for this student, put them in a temporary folder, fix the file names, non-trivial, students. And then I'm just going to open it in the browser. That's what I'm going to do. And yeah, that does pretty well with that, and it does save some time. And over time, the amount of things that I've asked the thing to do continues to increase. So it has done a little bit of continuing development. But you know, basically if I have a semester where it's like I really don't have time to like improve the script, I can just kind of let it operate, and it does sit. Like, with the script running, going at like max speed, I can knock an assignment off in like about a minute, which is pretty good. Like 1 minute per assignment is a pretty good marking rate. Considering like pre the script, I was spending at least 6 to 7 minutes per assignment. So that's pretty good. That's a lot of my life that I won back, you know? Those numbers, by the way, more are applicable to like friggin' server side, friggin' PHP, man. So, the moral of the story is don't listen to people who tell you you're doing something stupid. Go do it anyway. If people say, oh, that, you know, you're spending way more time on that bash script than you're ever going to get back. It's like, I know that. I can't help myself. So, reality. Who cares about reality? Many times it's not worth it in reality to write that script, right? It's only worth it if you get more time out of it than you put into it. And development costs a lot of time, right? But you should be bitten by the bug, you know? You should feel it in your bones. If I just wrote a little script, I wouldn't have to do that anymore, you know? This should be you as a developer. You should be like, man, I just want to write scripts right now. I don't care about my job. I want to write the program that does my job. Then I don't have to do my job anymore. As long as you don't let your boss know and replace you with your own script. But this is what you do, right? You're the only person who knows how to fix your script when it goes wrong, so you have job security forever. There you go. And you get to collect your paycheck, you know. hold down 10 jobs simultaneously, just keeping scripts going to keep your jobs going, right? Yeah, there you go. Make $1 million a year, retire at 30, go live in the Caicos, you know, or whatever small island in the Caribbean you prefer. So, bash scripting for fun and profit. If you're going to automate a process with a shell script, it should be something that's repeated many times. This is key. Going back to my example of grading students, right? If I have 120 students and 5 assignments throughout the course, how many times do I have to download 8 files from Canvas? 600 times 8. Right? Now, okay, 8 is maybe a lot. Let's say on average 3, right? I'm still using the little download thing on Canvas close to 2,000 times. Even if it only takes 2 seconds each, I have blown 5,000 seconds on that task, right? And that's actually okay, it's math time. Let's see here. So, if it's 2 seconds per task times 5 assignments times 3 files per assignment on average, well, yeah. Now let's make it 4, because that's probably more accurate, right? So, multiply that by 40 students per section, multiply that by 3 sections of whatever course, right? That's a big number. 5,000 seconds. How much is 5,000 seconds? 60? 80 minutes. Right? Which means that it's like an hour. An hour and a quarter or so. An hour and a third of my life gone. Literally only clicking the download link on Canvas.
Per semester.
Per semester, yeah. So if I'm a teacher for if I'm a teacher for 30 years, and I've got 3 of those a semester, right? Let's see here. 80 divided by 60, so 1 1/3, yeah. Multiply by 30 years of teaching times 3 semesters. 120 hours of my life, literally clicking download file, right?
I was gonna ask, what about don't you have multiple classes too? Not just one class?
Well, yeah, I did that one already. Yeah, 3. I'm assuming 3 classes for this semester, which actually we tend to teach 4, but they're not always courses like that, So, how many days is that? 5 days. 5 days of your life, and I mean not work days, 5 full days of your life, clicking the download link. Clicking the download link on Canvas, right? You see where I'm coming from? So as long as you spend less than 5 days working on it, you're up time. I think the initial version of that script I knocked out in an hour and a half too. So, but then again, I'm a brilliant programmer. Guys, I'm not a brilliant programmer. I'm a mediocre programmer. So, all right, have I sufficiently motivated all of you? Are you really want to know how to not have to do any work anymore? By doing a lot of work in the short term to save work in the long term? Right? If you're a good developer, that's what, All right. Bash script. In order to write a shell script, the very first line must be the shebang. This is called the shebang. All right? You have the octothorpe character Oh, by the way, over the summer, I was at like a pub trivia thing that I had to do, which was excruciating, but I still had to do it. And like, I was like, they were like, what is the actual name for this character? And I was like, I am a programmer, I know that. So here is some pub trivia for you. That is called an octothorpe. Octothorpe, exclamation point, shebang, bin bash. We should know a little bit now. We should have a rough idea what bin bash means. Anybody care to guess?
Binary bash.
So yes, this is the bin folder. So what is just slash? Where's that? That's root. So root, bin folder, this is where the binaries of our programs are kept, some of them anyway, bash. So the shell that we've been using all this time is actually located within the file system at that location, right? So if you want to call the bash program from within bash, you can do it, you just type bash. Let's see. Yes. All right, go away. Oh, you're not even. Gravy. Yes, come on. Actually, that boots quite quickly. I shouldn't yell at the computer. There we go. All right. So. Bash is bash, right? If we cd to bin, you'll see we have lots of different things. What do you do when you need to find stuff in a big long list? You grep out what you need to find. Here's bash. Here's all of this bash-like stuff. Yes?
Small question. Why does ls here listed out by line versus sometimes when we use ls it has it like actually together?
I don't know. Maybe there's an option to inline it. Oh, you know what it is actually. One of these might be really long. If like one of the file names is really, really super long, it'll do that. Doesn't seem like they're too. Oh wait, that one might be long enough. That one might be long enough to kind of disrupt that. Yeah. But yeah, you're absolutely right. Okay. Bash. It's a program. So, bash shell scripts are run with bash script name. Well, that's one way of doing it. There are two ways of doing it. The other way of doing it is to make the bash script itself executable. And if you make the script executable, you don't have to call bash. You can just run it like it's a regular program. I'll show you how to do both ways. The slides seem to prefer calling the bash program, but personally, I don't care which method you use, both work. Okay? So if in your assignment you really want to make it executable, go for it. Slightly more dangerous though. I like to live dangerously. Oh no. Oh no, I hate the slides. Alright. Come on. There we go. Alright, we can place a series of bash shell commands inside of the script. For example, a bash script. Make directory test1, test2, test3, and then display them. I'm going to use nano because I'm a painful normie, but I'm not going to do that in bin. So if you call cd with no arguments, it bops you back to home. make directory, nah, we'll just use home. Wait, can I increase the magnification here? There, that'll be a bit better, eh? Alright. Nano. Better still. Script.sh. Include shebang. Bin bash. By the way, if you wanted to target a shell other than bash, you basically just give the location of that program. You want to know something even more cool? You can even do Python. Do you find it annoying that you have to use the Python word every time you execute a Python script? Well, no more. So, make directory, test1, make directory, test2, make directory, test3, ls. Good. Exit. Bash script.sh. You can see it executes, and we have test1, test2, test3 existing. Look good? So far so good? Now, I will show you the other method by making a cleanup script. Cleanup scripts are the sort of script, that's another like very commonly scripted thing. Very often when you run something, like there's a bunch of temporary files that'll still be left hanging around. So deleting up the temporary files is just kind of like, you know, it's like a washing your hands after you go to the bathroom type operation. And it's the type of thing that we script. Keep in mind, scripts can call scripts. So your cleanup routine, once written, can be integrated into another bash script. Make sense? So, now, clean.sh, shebang, bin bash, rm, recursive, must be recursive because these are directories, test1, test2, test3. I'll give you a moment to take that down. Yes, so, what does the rm program do? This is review.
Remove.
Yes, deletes files and folders. What does the R flag do? Recursive, which means you delete a folder and all of its content. RM will not delete something, it will not delete a folder unless the R flag is set. Here's another fun little one. If RM is told to delete something that doesn't exist, it'll complain, but then it'll like kind of continue and exit. It's like, that doesn't exist, go away, continue on. Oh, pardon me, no, but it'll like, yeah, another thing is like if you don't have the permission to delete the thing, you know, or it's like, this is write protected, you sure you want to delete it? Anyway, sometimes it gives you these little messages, and if you just want it to just do it, I don't care about your stupid little messages, just delete. That's what the F flag is for. F stands for force. So if you just want to forcibly delete everything without listening to any of the things that it's telling you, or this is probably not a great idea. You just told me to delete root. Are you sure you want to do that? It's like, I don't even want to hear the message. That's what F is. A nice thing that Nano does is it tells you when you have extra characters. It's like, yeah, you left some extra characters on this line, that might actually have an effect here. So you have to be careful about spaces in bash scripting. It's a lot less forgiving than some other programming languages with respect to extra characters. Your bash scripts need to be tight and contain nothing except the script itself and anything that's in a comment. Okay? So, you can have blank lines though. So, second method, make this executable. To do that, you use the program chmod. Change, it's change modify, something like that. It changes user permissions, right? So, this column here, oh man, I'm sorry, I have to decrease the zoom out. There we go, that's better. This column gives you your file permissions, right? X means executable. So, for example, git config is not executable, right? We want to modify that. So chmod plus X, add executable permissions. What? Get out of here! Get out! Stupid. I was right in the middle of a thought, you know? Good grief. So clean.sh. You'll notice it's now green, meaning that it's executable. If you find it in this list, you will see it is now executable, has X's, where previously it did not. The way that you execute a program that is just hanging out in a folder is using // /clean executes the script. You can see the folders have been removed. All good? All right. That's like the full treatment of the, here, let me show you a quick bash script we did last week. So. Some important things. Comments start with the octothorpe character, similar to Python. Python uses octothorpe, right? The hashtag.
Why do you call it octothorpe?
It's called octothorpe. That's the technical name for that character.
There's nothing octo about that.
Beg to differ. 1, 2, 3, 4, 5, 6, 7, 8, my friend. Octothorpe.
Shouldn't it be 9? Because it has 9 different squares inside it?
Unless it's
But it
4.
has 8 points. So, yeah, I guess that would be the thorpe part.
The warts in the mouth.
So, comments, but that is Python, if I recall correctly. Python comments are that way, yeah. Name value. This is how you assign variables. So it's important to understand two things. Number one, shell scripts execute inside of a subshell. They do not share their environment variables with their context. Not by default. That's what export is for, actually. Right? When you export something, you're exporting an environment variable to the containing context. Within the script, a variable is created, and then it dies within the script. They're local. Right? Make sense? But there's an even more important thing. No spaces. Alright? Bash scripting is a little funny about spaces. Alright? Let me show you something. Let's say that x is equal to hello with a space. Hello, command hello cannot be found, but can be installed with. There you go. Whereas, if we remove the space, it's like, oh, this is a variable. Oh, okay. Right? Echo x. Hello. Right? So, don't put extra spaces in, because Bash will punish you swiftly and with the swift arm of immediate justice. Alright? This also pulls in an interesting little point. The difference between a string and a variable, when you're reading them, variables start with a $sign. This is similar, but not precisely the same, as everybody's favorite server-side programming language. Right? In the context of Bash, the $sign is a read this variable operator, right? It's read x. That's how you should think about it. That's why it's not here, because we're not reading x. We're assigning x. We don't need a $sign here because the equal sign tells us we're assigning to x. But when you're reading x, you need some way of distinguishing it from just x, because this is a language with no, this is a language where strings just exist and optionally have quotes, right? It's a very different kind of feeling language. By the way, on that subject, right? You remember that from PHP?
I was just about to talk about that. Like the one with the $sign is like double quotes, and then the other one is single quotes.
Yeah. See, this is where PHP actually picks up those semantics, right? So, when you include double quotes, we are not interpreting, we are interpreting the variables that are inside of that. So why would you need to do that? Right? Well, it doesn't really work very well with that code. Here, let me show you. Just give me a moment to set up a different example. File.txt, some stuff. Exit. Nano file2.txt, some other stuff. Right? So, right? This is what double quotes are used for. So it's assuming that file name contains a space character, right? But if you leave this off, it's like, oh, file, another file. Because the space character separates arguments in Bash, right? But if you want to actually include it, it is possible to make nano file2.txt. This is now one file. Don't ever do this. Right? Now I have a file called file.txt, file2.txt, and file.txt, file2.txt. That's one file name. Right? Now, this is don't ever do this, whereas this is the two files individually. So do you see why you should never use spaces in file names and folder names? Alright? Occasionally you have to include a space. When you have to include a space, use double quotes. But try to avoid spaces almost at all costs. Almost at all costs. Make sense? Okay. Any questions? All right. So, and we already know echo. So, here is an example, which is actually quite similar to the stuff I just did in Bash. See, the fun thing about Bash scripting is I could literally just take my Bash history from the last couple of transactions and pop it into a Bash script, and there you go. Like, Bash history. This is, it doesn't appear to be my Bash history, actually. Okay, there's a file where it is somewhere. There we go. All right. Moving on, moving on.
Maybe if you close the terminal and open it back, it shows you.
Yeah, I think, yeah, you're right. I'm not gonna try it though. You can try it on your own time. So, all right. We know how to write to variables, we know how to echo stuff. One thing that's important to understand is that when I do a command in the command line, I don't have to show you that in a file. It literally works the same way in the file. All you'd have to do is put the command in the file, and it works. Okay? So, this is an interesting one though. This is new information. Command line arguments. You'll notice that many of the programs that we've been using so far have taken command line arguments. In order to write a shell script that's useful, you will have to take command line arguments too. There is a set of special variables which are set up in Bash scripts which give you precisely these. All right? They are the numeric arguments. We're starting to angle towards part 3 of assignment 2 now. Everything we've talked about so far, you now know enough to do part 2 of assignment 2. All right? Now we're going to talk about part 3. The first argument is always the name of the command, interestingly. Then, first, second, third, numeric, right? The octothorpe, in this case it's meaning number, is the number of command line arguments that you were given. So, let's try her out.
Question.
Yes. Oh, sorry. Yes.
The numerical integer, is it an integer or does it go past 9?
It is an integer, and yes, it goes past 9. I'm pretty sure. You like in practice, you'd never hit 9 unless you were piping stuff in, right? But you could very well be piping stuff in. So in fact, you will be. So yeah. Don't worry though. We've got a bit coming up. which transforms, like, you can use a bash variable to get argument number x, which is like how you actually do part 3. We're getting there though, we're getting there. So, first let me demonstrate. Now, echo args.sh, bin bash, shebang. That's actually harder than it seems. There you go. Alright. Hello. This is a systems test. Ooh. So there we go. We get echo args.sh. Hello, this is a systems test. 0, 1, 2, 3, 4, 5, 6. Zero, 1, 2, 3, 4, 5, 6. Does that make sense? Very good. Echo provided arguments colon. There we go. Provided arguments 9. So let's now test. Seven, 8, 9, 10. Oh, interesting. So it is rejecting it beyond 9. There you go. Okay, so for arguments above 9, you're going to have to use the loop way of doing it. Good. All right. Good. So, any questions about that? So the programming languages properly stated that you've been using so far, Java, Python, C#, etc., they have the ability to do this too, right? To take command line arguments. Normally, they will be bound to, like every language has a slightly different way of doing it, but in general, you should be looking for argv and argc. Right? Anybody heard of these things before? So, if you want to take a Java program and do what we just did with bash script, take command line arguments. Look for these, look for the documentation on how to use them. Java, I'm sorry. This is like pretty much everybody except Java. You know how, okay, who can read off to me from memory the first line of the main function in Java? Public static main string array args. String array args is actually just argv, which has been bound. Argc is the size of argv. But if you look for this, like if you look for this in Python, you'll find it's pretty explicitly argv and argc. So that's how you do it in a regular programming language. Okay? So, good. we need a break? A break before we get into control structures?
Yeah.
It's like this is like a good like natural dividing point. So okay, we will have our half-hour break. Thank you very much for your time and attention this first half. We will resume in half an hour. Please be ready to resume class at 5:42. Thank you very much. If so, we're starting with that. So, I'm glad you all laughed at that because that's like, in my repertoire, that's one of my most programmer jokes. So, one of the things that distinguishes Bash scripting is that in addition to being a way of organizing Bash commands, it's also a proper programming language. You can just program in it. It has loops, it has if statements. We're going to start with for loops. We usually start with if statements, but this time we're starting at the back with for loops. So, there are multiple different types of for loop that you can use. They are sometimes more or less, what you expect them to be. For I in command, do stuff with I. Alright? So, $ with round braces means execute this and replace this with the output. So, for example, let me start a new Bash script. Now, where are we? Here we are. Loops.sh. Shebang, bin, long, bin, bash. There we go. So, for I in a command that returns multiple things. For example, ls. Let me see, I'm forgetting my syntax. Yes. So, one interesting thing to note instead of opening and closing curly brace, we have do and done. These are our loop delimiters. Okay? We can then do something for each I that's returned from the call to ls. Echo, I found a file called I, file/directory. There you go. I found a file directory called clean desktop document, etc. Right? So, essentially, what the loop is doing, it's taking the raw output of ls, which is all these things separated by spaces, and it's separating those things out by splitting on spaces, feeding those values into I one after a time, one after the other. It's quite similar to a Python for loop. Make sense? So far so good? Very good. Just to demonstrate the structure for you a bit.
Can you open the file again?
Yeah, absolutely. There you go.
Thank you.
Very welcome. Just to demonstrate the structure for you a bit, let's say x is equal to the string 1 little, 2 little, 3 little programmers for x in the variable, or I should call that something else, just confusing. For q in x, do echo q dot 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 done. See? It's just, like, it's not thinking about ls, right? ls executes, but once ls is done, the loop isn't thinking about the command. All it's thinking about is what does it produce as output. That's why substituting this string works. The for loop is splitting on space characters and simply feeding those strings into the loop one after another. Keep in mind, this is bash, and in bash, your variables are strings. Always strings. Always strings, always and forever. If you want to do actual math, you have to get a little bit fancy. Just a little fancy, but you have to get fancy. Okay? Make sense? So far so good? Okay. I'm sure you all know how loops work. Yes. So, now let's imagine that we wanted to loop over command line arguments. $, curly brace, exclamation point, and then the name of the variable does that. This is the reason that I highly recommend desk reference. So, I think I've probably made this suggestion before. A thing that every single one of you should do: take little character groupings like this, write it down on a piece of paper, post that wherever you do your work. Right? Here is my weird bash reference. Right? Because there's effectively no way to remember that. Right? You just have to, and that's part of the reason that this course has no exam. Right? It's almost impossible to actually remember that. You should remember that it's possible and that it's bound to a character group. It would help if you gave yourself some reference for it. Okay, make sense? Yeah, there's a lot of stuff like that in Bash, yeah.
Why the double brackets?
Double brackets let you do things that look more directly like programming things. Yeah, there is a reason for that. Double bracket environment is your math environment. What it's actually doing is it's taking whatever is in the double braces and redirecting it to another program, which I can't remember the name of. But what Bash is actually doing is sometimes very arcane. So it's good to just, double braces means math mode. Or proper programming mode if you prefer. So let's try this little loop out, shall we? For I is equal to 0, I is less than number of arguments, I plus plus. Just make sure I did that right. Yes, I did. Do, done. Echo argument I is upside down I, regular I. Yay! Let's try her out. One, two, three. There you go. Ah, we're stopping one early. Off by one error. Throw a little old weak equal sign in there. And there you have it. Argument 0 is this, 1, 2, 3. You can access them programmatically. Let's see how many it'll do. Quite a few. So we've broken through our limit of only accepting 9. Look good? Yeah. Unfortunately, Bash is just that kind of a language where there's a lot of like, well, I can't do it this way, but if you do it that way, it works type stuff, you know? We're not, like, it's important to understand that we're not working with a language that was designed, like, from the outset to be consistent. We are, in some senses, working with an unholy combination of many, many people's programs. And it all's cobbled together and held together with sticky tack and shoestrings and bubblegum. And, you know, yes?
Is the arguments like fixed? Is it gonna stay at 39 or is this gonna change?
What do you mean, the argument's fixed? What?
I'm like, I was just thinking along like so like, you know how like people just do random inputs and stuff?
Mm-hmm.
Like randomly generate certain amount of numbers, so I was thinking, is it like just randomly gonna be like some certain amount of arguments or just gonna stay at like argument 39 is n?
So the reason it's showing me argument 39 here is because I entered 39 arguments, right? In the previous command. If I take one off, I now have 38. So this isn't a random number,
So it's like not based on input.
Yes, it's based on the input.
Okay.
Yeah. No, I didn't magically smuggle random numbers in. Yeah. I just did something random. Garbage in, garbage out. Good. Any questions? This should be recognizable to all of you as the final component that you need to do part 3 of assignment 2. So, I kind of already said it, but this guy, $ round braces, this is execute command. I find that I use this guy most frequently either when writing a loop or when doing something like this. X is equal to execute ls. Echo x. There you go. You can use it during variable assignment to bind the output of a command to a variable, which can be useful. Yes?
What happens if I call the variable that refers to the file that's running?
What happens if I call the variable that refers to the...
And
Sorry?
I use that as an argument. So, because you're saying that the file, so the command to run the file is bash test or whatever the name is.
Yep.
What would happen if you had a file or a line within your code that referred to running the file itself?
Oh, you want to break it. Let's see. The worst that happens is I just kill the terminal. So let's try that. Nano bad idea.sh. Not that it was a bad idea because it was like, it's bad to explore ideas, but because this will probably break the machine. Echo. This is the song that never ends. There we go. And then bash bad idea.sh. Bash bad idea.sh. There you go. Oh, we have a message go through there. You can see it's
Still running.
resource temporarily unavailable.
Interesting. Why did it start ending?
Oh, probably can only support so many subshells.
Oh, so every time that's running, it creates a subshell?
Yeah.
I see.
So yeah, by like this iteration, we probably had, you know, 500,000 subshells.
Yeah.
Which is probably as many subshells as you could ever want, unless you're doing silly things like recursively calling a script from within itself, without, you know, it's an infinite loop. That's an infinite loop.
Okay.
I'm glad we tried it, and I also am glad that we demonstrated Control-C gets you out of a lot of sticky situations. Any other questions? Very good. So, where was I? Oh yeah. Yeah, you can use this to bind the output of a command to a variable and then use that output. It's sometimes pipes get really long and you don't want to pipe that long. You just want to like just put it in a variable like a normal person, and that's how you do it. Okay? So backticks does the same thing. Note that this is backwards apostrophe. That way. It's equivalent. Incidentally, PHP also supports this syntax. You can run bash commands from PHP if your script has sufficient permission levels by using backticks. So, yes, good, yes, good. Several other forms of for loop exist. We've already seen an example of this one. This is your very, very highly traditional for loop from C/Java. There are a bunch of these. You don't have to know them all. Yes, yes, yes. You can just provide numbers. You can do that. You can do this. So bash scripting is one of these types of environments where there's literally 10,000 ways to do anything. It is not of utmost importance that you find the most efficient way of doing something. It is important that you find the way that works for you. Right? So, if statements. If statements have fit at the end. Because of course they do, right? So, again, rather than having closing braces and opening braces, if itself is the opening brace, and fit, which is if backwards, is the closing brace. Isn't this a delightful language? Yes?
Clarification, is the indentation within the loop and if important?
No.
Cool.
Yeah. It's important that commands be on their own line, but I believe indentation is optional. So, CMD command, that can be a command or a sequence of commands. That would be true if CMD returns 0 and false otherwise. So you can run this using a command, but most of the time you won't, because most of the time things like ls give you things like lists of, like the outputs, the thing that it outputs to standard output is rarely going to be a 1 or a 2 or a 0, right? So okay. You can do else cases, all right? We'll get to that. Put a pin in that. What do we got here?
Also,
It's elif, our old friend from
Python?
Python. Yes. PHP is actually, I think PHP supports all 3 ways of doing it. So elif is bash and Python. Else if normal languages, Java, C, C#. JavaScript is a normal language under this definition. Oh no. Else safe, just PHP. Literally, like this also works in PHP, so I don't know why anyone would ever do this. But you can literally say else if with no space, and that's valid in PHP. So, again, everybody's favorite server programming language, right? Yes. Notice one thing though. If you're breaking it into an else if chain, you also need if then. Alright? So if then, elif, then else, and then you end with a thing. Alright? Okay. Again, this is the sort of thing that you put on your quick reference sheet. How the frig does an else if work in Bash again? There you go. So, among the things that's useful to put in an if statement is the return status of a program. Some of you may remember from PHP, you probably used a statement called exit 0. Right? I was actually just talking about exit 0 today in my PHP class that I teach before this. Exit 0, what does the 0 mean?
Like the process?
Hmm?
Process?
No, it's not the process. It's its return status. Right? So when you execute a program, one of the things that it reports back separately from its standard output, right? It's like it returns a few things. Standard output is one of the things that it produces. Its return status is another thing. It's separately recorded by the operating system, right? It's an integer. If it's 0, this means, generally, everything is fine. Program executed and terminated normally. Nothing to see here. Exit 0 means PHP script exited fine. Nothing to see here. So here's another one for you. Earlier today I had you rattle off the main declaration from Java. Let's do it again. Public,
Void.
let's stop on void, all right? So Java programs don't return anything, right? In C, and I believe in C++, the main function for sure does have a return status, or it does have a return type, and that type is integer. So when in C, you return from main, whatever integer you pass it becomes the return status of the program. Right? So, it's important to know how to read these things. It will tell you if an error occurred when the program executed, right? So, diff is an example. Diff's exit status, if it's 0, the files were the same. If it's 1, differences were found. And if it's greater than 2, greater than 2, then the program encountered an error. One of the sorts of errors it could encounter is the file you're asking me to examine doesn't exist. Right? Question?
What's the example exit of the differences, like an example of a difference between the file?
Oh, I'll just show you in
Okay.
general. Yeah. So let's say I have nano A.A contains A, nano B.B contains B, right? Cat A.A, B.B, A and B, right? Diff A.A, B.B. That is, this file contains A, that file contains B. That's not the same. That's what diff is saying, right? However, I don't know why you would do this, but if you did, if you diff A against itself, it's like, yeah, no differences, right? So, another special character group to find the return status of a program, the return status of the program which just exited, just finished, $? So diff, when the two things you're diffing are the same, gives 0 as its return status. If they are different, return status is 1. Right? Now this doesn't seem like it's all that useful, except if you then use this guy inside of an if statement, you now have a block of code that will execute conditionally on whether or not the previous operation succeeded or failed. You had a question at the back?
I think I kind of figured it out, but I tried running a program that doesn't exist and then running the echo $? And the return code was 127.
Ooh, cool. Let's see here. Blork, command not found. Yeah, 127. That'll be one of Bash's exit statuses.
Oh, okay.
Yeah. So the thing that you have to understand about like exit status is that they are very specific to the program that you're running, right? 0 universally or almost universally means nothing to see here, everything was fine. But anything that's not 0 means something, right? Way back in like the 1980s and 1990s, you would have great big tomes of operator manuals for these programs that would have listed in like the back appendices what every single status, output status meant for a particular program. What does it mean when CP gives me negative 3,272 as an exit status? It means that the program, the disk ran out of disk space while I was attempting a copy. Stuff like that, right? Every error that's like a proper error that it encounters, it returns some kind of exit status. Does that make sense? Cool. Yeah. So you can write if statements to do that. So, for example, safe cp.sh. Not quite the same thing as scp. So, in bash, let's say we are cping 1 to 2, right? Which is to say basically nothing, right? There's no difference yet between this script and just calling CP. But now, if non-zero exit status, echo, use CP properly, you dummy. Right? So, save, exit, let's see. If we bash safe cp a.a to c.c, oh, come on. Unexpected syntax. Let's see here, what am I doing? What am I doing with my life? You need then? Is that an error in the slides? Did I forget that? That might have been an error in the slides. Oh, that's a different error. 0, command not found. Line 4, okay. Line 4. I think I've been lied to. Kind of feels like I've been lied to. You got an example for me? Oh, they want you to. I guess you could do it that way. Let's try it that way then. Still no, okay? Ah. See, all right. And that's an image too. All right, we'll try it your way. We'll do like the exact thing in the slides, Kevin. There we go, somewhat. So, and if we compare like that, let's see here. Surely you don't require the else case.
Are you like hard coding the A.A and B.B?
I am, just to see if it'll work.
Okay, but that's why it showed you the same thing twice, huh?
No, yeah. Oh, that's true, that's true. Let's just throw that in there. There we go. Yep, okay. Now. Okay, so yeah, okay. No, you're right. A.A. There we go. Yeah, okay. So it is working. But now let's break it. 1, 2. There we go. A.A, B.B. We get the dot, dot, dot. Okay, good. A.A. Okay, variables are working. So I wonder what the problem was before. Oh, anyway. Because like, if I echo $, or if I echo that, I get it. Yeah. I don't know. This is normally the part where you look up an example of it being used on the internet. This is the flavor of bash programming, by the way. I know that that was perhaps a bit excruciating to sit through, but I always find it useful to do that kind of thing in class because it's I always think it's useful for you to watch me have a problem because the way I solve the problem might be instructive to help you solve problems. So let's recap, what did I do to try to solve this problem? Well, the first thing I did, I was trying to use $? Here, right? The first thing I do is hard code in everything, right? Get that working. Okay, that worked. Next, try the variable substitution here with the $1, $2. Okay, that worked too, right? And for us, for the purposes of this demonstration, that demonstrates what the if statement does, so we don't really have to go any further. But it's pull it back to something that you're sure will work, right? Or close to, and then introduce things one at a time, right? Throw things in one at a time, test it to see if it works. Bash scripting, it's a little shy, you have to coax it out, okay? All right. So, good. So I don't like the way that this does it. I'm going to show you a better way of doing it. You can also write proper mathematical expressions in theory using square braces. However, you'll notice that you're using things like the EQ flag to test for equality, the LE flag to test less than or equals. Wouldn't you prefer to actually use the proper symbols for these things? Well, this and yours could be yours with just the following. Two braces. So, you guys starting to get the hang of this language? Kind of starting to feel it a little bit. You know what it's how it thinks about itself, right? So 4 equals 5. Yes. No. No. No syntax error. That's the main thing. 4 greater than 5? No. Okay, you guys get the idea? So within the double square braces environment, you can use regular mathy stuff. Otherwise, you're actually making references to a program called test, like test for EQ 5, and then I think it gives it as its exit status. Yeah. So, that's what's going on behind the scenes. The single square braces is wrapping that. The double is I'll just let the programmers use the programmer language then. Sound good? So, just so you know, for this slide only, I will be very disappointed if I see anybody do this. Okay? So, because here's the difference, right? So why this roundabout way of doing things, right? Well, this is the way you compare equality between numbers. If you want to compare equality between strings, that is single equal sign. under the same regime. Or you can have double equal sign do everything for you. These ones though, these are ones that you'll have to bump back into single square brace mode for. File exists and is readable. File exists and is writable. This is a directory. This is a file and not a directory. This is the size of the file size is greater than 0. Right? And or. And or go back to double brace mode. Make sense? But these guys here, which are hella useful, right? Well, this one is useful. Those guys are not something that exist under double brace notation. Okay? At least not to my awareness. They probably do actually, but you know. Yeah, okay, good. Access environment variables, we can set environment variables. Yes, so the thing that differentiates a variable in a bash script from an environment variable is that you export the variable to the environment, right? That's what the purpose of the export is. This sends it up one level, declares it global, if you wish. Make sense? Good. Enough said? Hopefully. We can also check to see if an environment variable exists and is set to a non-empty string using the Z flag, which returns true if the variable does not exist. So, 0, variable name. Z stands for 0, meaning, I guess, this is not here, right? So, you can, using that, create it if it doesn't exist, if it's necessary later. Make sense? Sound good? Any questions? Have I bored everybody to tears? No? A little bit? Okay. Well, I know. I know it's the basic stuff, but yeah, okay. I did the examples at the same time, so that's concurrent. All right. Good. Everybody knows everything they need to know in order to do assignment 2. Any questions? Shell scripting in general?
When are you gonna post it to the YouTube?
Yeah, it was a little bit late last week, I'm sorry. Hopefully tomorrow. Yeah, hopefully tomorrow. Sometimes the week gets away from you, you know? I've been obsessing recently over getting LaTeX documents to self-randomize so that they can generate like randomized testing, like multiple choice questions that like permute the answers. I've got it working. It's great, it's grand, it's glorious, but I'm not going to show you. So, alright, so let's talk about VI. So, it is the position of this course that VI is the superior code editor. So, actually, I'm even going to support this. We're also, in this unit, going to talk about VS Code, but we'll talk about this one as well. Because VS Code, you can't do in a pure command line environment, and often you'll be in a pure command line environment, right? Especially if you're working on a remote server or inside of a Docker container or something like that, something that doesn't even have a GUI, right? So, did I show you guys in this class the developer survey for 2025? Possibly I did. Well, let me just show you. There's a bit down here. Yeah, thank you. Here we go, dev IDEs. Oh, I just did the thing. All right, so. Unfortunately, Visual Studio is sitting at 75.9% of market share. But the only reason that they did this, they've managed to achieve this, is because they bought out their competition and shut it down. There was a very popular editor embedded in the GitHub ecosystem called Atom. When Microsoft bought GitHub, they shut down Atom, even though they said, oh no, we definitely aren't going to get rid of Atom. Everybody loves Atom. We're not an evil corporation that's buying out our competition in order to shut it down. That's not a thing that people do. Well, that's what they did. Visual Studio, I'm surprised anybody at all still uses, but you know, there you go. Notepad++ may surprise you by being the third highest ranked text editor. That may surprise, it surprised me. Then IntelliJ, lots of people use it, mostly for writing Java though. Java, Kotlin, Maven, that kind of ecosystem. But Vim, and you'll notice, of all of these, right, this is definitely the only one like that's command line only, right? So yeah, all the rest of these are GUI programs. So among command line tools for editing files, Vim is the one that's preferred by all respondents. Let's see how about professional developers. Oh, there you go. So, interestingly, slightly more popular among all respondents than professional developers. Learning to code, you know, okay. Professionals that use AI. Learners that use AI. What's a write-in? I don't know. All right. Anyway, Vim is actually used. It's actually used. Okay? You may think to yourself, why? Why am I using Vim? This is why. So, VI, pronounced VI, is a text user interface editor that dates back to 1976, which was before the moon landing. User interface, yes, that's satirical, actually. Although you're actually talking about the same kind of historical era as the moon landing. On modern systems, when we use VI on the shell, it's sometimes really Vim, which is an improved clone of VI, which is fine. VI is one of the most widely used text editors to this day. Why? Why do we still use it? Well, it must be included as part of the Unix specification, and Linux machines are also universally include VI, so it's highly portable into everywhere. It's the editor that comes with the system by default. And you might be saying, well, that's not terribly impressive. Notepad comes with Windows by default. Nobody uses it for serious work. So, technically, well, Visual Code will run Mac, Linux, Windows, and the browsers, so, you know. But hey, just because it's more, you don't get points for being more universal if it means you support Windows. Sorry, guys. That doesn't get you points. Being able to edit files on the command line is important if we use SSH to connect to another machine, such as CS Unix. CS Unix has VI. It doesn't have Visual Studio Code. Switching from the shell to Visual Studio Code also slows us down as our hands leave the keyboard to use the mouse. VI is ideal for small edits to files. That's right, folks. That's the level at which we are optimizing our workflow. Mice are slow. Whoever introduced the mouse into the computer was merely trying to appeal to painful normies. Keyboards are where it's at. And if you don't know how to touch type, get out of my classroom. I'm kidding, of course. You don't have to get out of my classroom if you don't know how to touch type. You should learn how to touch type though. It like, for people who work with keyboards for a living, you should know how to touch type. Touch type is the term that they used for it when I was learning it in school in the 90s. I think they just call it typing now, but the concept is you use all 10 of your fingers to type instead of a subset of your fingers to type, right? A proficient touch typist can hit word per minute numbers of 60 to 70, or higher than that if you're really good. Whereas most people cap out around 30 for any of the non-trained methods they use. So you can literally type twice as fast if you're a touch typer. At least! So, there are developers that use VI for everything. There you go. Modern editors such as Visual Studio Code have many powerful features and plugins that can improve productivity. You can bet your bottom dollar that VI has no plugins for the bloody chatbot, so, you know, if you over-rely on the chatbot, then VI is probably not for you. Yes?
VI might not, but Vim, if you have your language server set up properly, you can use like GitHub Copilot.
Really?
Language server and do everything.
Fuck. Never mind then. Ah, crap. But it takes setup, right? You gotta do some configuration.
Yeah, a lot of configuration.
Alright, so people like probably would just use Visual Code, Visual Studio.
I use Vim, and I have it set up.
Yeah.
It's a pain in the ass.
Yeah, that's what I'm trying to determine now is what's the ass pain threshold for setting that up, you know?
It's not that bad. You can just copy someone's configuration from online usually, but it's
Yeah. Alright, well, see, this is what I'm talking about, you know? Vim can do lots of things that you don't even know it can do. Lots of things I don't even know it can do. There you go. So you use Vim like as a main thing?
yeah. Well, I use NeoVim, but
Yeah.
it's just with a Lua interface for the plugins and stuff.
So, how do you find it?
I love it.
You love it. Why do you love it?
I don't know. It's really fast. You don't have to sit there and wait for stuff.
There you go. That's usually a pretty good, like, computers do a lot of wasting your time, you know? Microsoft in particular. Like, one thing that really shocks people about Linux is like how fast it updates in comparison to Microsoft Windows. Like, my poor wife and her poor old laptop, it's like, she only boots the thing up like a few times a year, to do like taxes and stuff. But like, it's like, oh well, I better start it today, because by the time it's gonna take 3 or 4 days to do Windows Update, and then by the time it's the weekend, I'm gonna, you know, I'll need my computer to do the work. It's like, you shouldn't have to plan to turn your computer on 4 days before you need it. Windows, stupid Windows. Anyway, it's still very useful to know enough VI that you can use it, if necessary. Otherwise, hope your system has Nano. That's one thing that, you know, I actually had to request that they install Nano on CS Unix. They did it, but systems don't come with it by default. They come with VI by default. So if it's like a very default-ish system, then that's what you got, right? All right, so we can open VI by just using the VI command. I will attempt now to use VI instead of Nano for the rest of the course. There are a number of variations that allow us to open a file and to edit the file at different positions. So, let's see here. I'm sorry if this is going to be painful for you to watch. VI myFile.file. Behold. So, some command line options. Plus n, file name, edit the file beginning at line n. We would need a file with some, length to be able to do that. vi plus file name, edit file name beginning at the last line, which can be useful if it's like a really long file, right? As opposed to like, you have to understand like you're not in a command line, you're not in a GUI tool where you can just like mouse to the scroll bar and scroll all the way to the bottom. Like you need like, there's definitely an inbuilt shortcut to jump to the bottom of the file, but you can do it very quickly from the command prompt. R is recover after a system crash. So a thing that you will find quite a few of these command line Linuxy editors do is they'll keep a backup file somewhere on your system. Normally it's a hidden file, sometimes it's not a hidden file. I'm more familiar with Emacs. It puts a little tilde on either side of the file name, I think. And that's your backup file. So if something goes wrong, you have your backup file and you can restore backup files. In the case of VI, the R flag is your restore backup. Then VI plus / pattern, I think that's supposed to say pattern, edit file name starting with the first line containing pattern. So you can jump to, say you're looking for a particular function inside of your gigantic source code file. You can jump to that function by providing the opening line of it. Make sense? So far so good? So, VI has two modes. Insert mode, keystrokes will result in characters appearing on the document. And command mode, keystrokes will result in commands being executed. You end up spending a lot of time in command mode using VI, perhaps more than you would think, because there are commands for deleting text, lines of text, lots of things. Insert mode is really for adding and editing text. So one way perhaps to conceptualize it, and I hope you'll correct me if I'm wrong, many of these types of commands, when we're using other editors, require us to hold down the control key or the alt key, right? In VI, we are in hyper-efficient VI world, right? Holding the control button down with your pinky reduces your range of motion and your speed of typing. So, we have a command mode that we enter rather than holding down the control key. Make sense? All right. So, VI initially starts in command mode, which is, of course, the absolute first barrier to entry most people experience with it. If you have this loaded right now, try just start typing. Nothing, right? Weird stuff. Nothing going on. In order to edit, you need to be in insert mode. You enter insert mode by, well, actually, how do I, no, I must have pressed I by accident. Let me, oh. Quit. There we go. I. Where's my little thing saying I'm in insert mode. Don't use the scroll wheel. Where did- oh, goodness. There we go. This is text. Be careful. The eye can be dangerous. There you go. So, you enter command mode when you are in insert mode by pressing the escape key. You are escaping to command mode. We can choose where to begin inserting the text by using a number of different options. Using I is most common, but you know, that's kind of like that's your place everybody starts, right? So, I inserts text before the cursor, A after, capital A, end of line, lowercase o, open a line below the current line, uppercase O, open a line above the current line, R, replace the current character, capital R, replace characters until escape, which is in overwrite mode. It's kind of interesting. When I'm teaching, like, you know, second semester Java and that sort of thing, I will have students in the class who unintentionally put their editor into overwrite mode using the insert key, and they have no idea what's going on with their computer. And it's like, oh, that button does that, you know? So overwrite mode is an actual, like, editor mode in this case. Make sense? So. We insert, there we go, before the cursor. Oh, goodness. There we go. Escape. Escape. Capital O, new line. Escape O, new line. Right? It takes some getting used to. Yeah. I'm going to try Vim though, because I think in this case we are actually in VI and Vim might be a bit easier. So :Q exclamation mark is quit without saving changes. Q is just quit. WQ is write and quit. W is write. Write means save. So quit. Let me try Vim. It's not even installed. Okay, sudo apt install Vim. Come on. There we go. Vim file.file. Yeah, this is the one I'm used to. Vim actually tells you if you're in insert mode, and the cursor works a bit more like you would expect it to. Hello, this is an editor. You can cursor around and it works. Cursor. Arrow keys. They work. So, Vim with an M. VI improved. I can see the improvement already. So I'm gonna once again have to depart slightly from the slides. I think everyone should use Vim and not VI. Although, as you'll note, I did have to just install Vim, right? So, in contexts where VI is all you have, VI will be all you have, right? So, and that will be a non-trivial amount of the time. Of course, that's true if it's any amount of the time at all. So, save. Right, there you go. Escape, W, writes the file to the file system. There we go. So, when in insert mode, some configurations of VI will allow you to move the cursor using the arrow keys. Some will not, as we all found out. Other configurations of VI will not allow you to do this. The idea is that you're supposed to be moving the cursor in command mode, and then basically staying in insert mode only when you're actually inserting text. So you can't even hit the left arrow to move the cursor back after making a mistake. Notably, we can't use the mouse to move the cursor around either, although this makes more sense, right? It's a command line environment. The mouse is not supposed to do anything, so there you go. All of this feels very restrictive and initially makes for a frustrating experience. But if you take the time to learn the basics, VI can become a very fast way to edit files. Although, you said you use NeoVim?
Yeah.
Yeah. So I imagine the arrow keys work the way you expect them to in NeoVim?
They do, but I don't use the arrow keys usually.
Yeah. See, this is exactly the sort of VI person that response that I'm expecting, you know?
Yeah, you use HJKL to move the cursor.
JKL, eh?
HJK, yeah, H is left, J is down, K is up, and L is right. It's less, you move your fingers less.
Alright, let's try it. So. Oh yeah, look at that. Oh, except, wait, I is insert mode though.
HJKL.
HJKL. Oh, okay, alright.
It's just a line from H to L, I think.
Huh. That would take getting used to.
It takes a long time to get used to, yeah.
Okay, so back and forward are H is this way, L is that way, J is down, and K is up. But that's true because you haven't moved from home row, so you're not moving over to the arrow keys to use the arrow keys.
Yeah, it makes typing a lot faster.
Oh man.
Can't
Like-
you just reorganize your thing? You just reorganize.
I aspire to this level of intensity. I'm too much of a painful normie to use this program, I think. At least VI. Vim I can manage. If you can't use VI, try using Vim. If you can't use either of those, use Nano, I guess. But try, because it's one of those things where if you put some effort into it, you'll be able to do things faster. So, alright, good. Yep. Ah, there you go. Command mode. So arrow keys are very close to your home row. You've got H, J, K, and L, which, there you go, as just demonstrated. We can also use more advanced features to move the cursors in other ways. 3W will move the cursor 3 words to the right, and 8J will move the cursor 8 lines down. So that's, oh man, like, at a certain point, I kind of stopped using editors where you can't, like, there's no shortcut to go to line, you know?
There isn't
Yeah, what is it?
a colon and then you type the line number and it jumps to the line number.
See, it's so useful, because it's like, this is so immediate, I'll need to jump to a particular line number. It's not even down to a shortcut key, it's just numbers or line numbers. It's great. Here we go. So, if we go to line 2. Line 2. Oh, but I don't know. Those lines aren't zero indexed, so, you know. Yeah? Is it really for programmers if it's not zero indexed? I ask you.
Well, it is, at least U of M is written in Lua, I'm pretty sure Lua starts its array indexes at 1, so kind of makes sense.
Oh. Oh, wait, no, 0 also brings you to the top one.
Oh, okay.
Yeah. Really? Lua starts indexing at 1?
I'm pretty sure it does, its first array index is 1, yeah.
Is it the only language that does that?
Probably.
Good grief. Yeah. I bet it's so that people can like write their mods for this, that, or the other in it. So, let's see here. 2J. 2J? That deleted something. Strange.
I think it might just be like when you did just using the X space. I think that's why it's moving it, cutting the.
Well, we should move on. I want to get through at least these slides today, so we can use a repeat factor number in front of any of these commands in order to do stuff. So, we've got all of our directional keys for moving the cursor. We can put a number in front to move that many positions this way or that, which, you know, all of you painful normies out there needing to move 8 spaces to the right, hitting the key 8 times. Good. Have you ever programmed?
Can't you just use a tab function?
Well, not in command mode, and I'm not talking about like inserting spaces. I'm talking about like moving through the text that's already there. Go to the end of the line, beginning of the line, end of word to right. Oh, 0 is the beginning of the line. Okay, that would be why it's not a line number. Sentences. Braces give you beginning or end of sentences. Curly braces give you beginning or end of paragraphs. So, those might be interesting. This is paragraph simulator. Oh man. Is that an old joke now? It's like, this is X simulator. There we go. And command mode. Up, down, up, down, up, down. Beginning or end of paragraph using the curly braces. There you go. So it goes. Words, round braces, round braces, there they are. Oh, sentences, I'm sorry. So they're detecting punctuation marks. There you go. All right, cool. To undo the last deletion, its insertion, etc., you can use the U command. There are many ways to delete text. DD deletes the current line. We can again use a repeat factor such as 5DD, which will delete 5 lines starting with the current line. So, to DD, boom. Not an editor command. I know what I'm doing. I'm putting I know what I was doing wrong. I was putting the colon in. That's wrong. Yeah. Yep. Alright. And then undo. Undo. There we go. Make sense?
What's the command for undo?
Just U.
What do you do?
Mhm. Man. I'm not sure it's useful to run through this list. Do you guys think it's useful to run through this list? I don't think so. Yeah. No. Alright. So, copy pasting though, that's something you probably need to know how to do. In VI, copying is also referred to as yanking and pasting as putting. So, for pasting, capital P pastes above the current line, lowercase below the current line. For copying, we can use Y preceded by a repeat factor number and preceded by a unit of measure. W for words, Y for lines. So, for example, say my cursor is down here, beginning of the line. I say yank 4 words up, 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 down, and then P. There you go. Copy paste. It seems that it's not 4 words. Maybe it's counting the exclamation point? Yeah?
Yeah, I think it's kind of an exclamation point.
Alright.
That's why.
Well, the way to check that would be yank 2 words and then P. Yeah, this counts as 2 words.
Also, if you navigate with W and B, if you hit W, it doesn't jump to the end of the exclamation point. You have to like go through it.
True. There you go. Cool. All right. This is the example I gave you. Yank 3 words, yank n lines, yank to the end of the line, P for paste, or put, as it were. Make sense?
The same thing.
Sorry?
I'm guessing copy is the same thing, we just use C instead of P, right?
No, copy is Y, because it's yank.
Oh,
Yeah, yank is the word instead of copy. Because I imagine VI was made before, like, these words were encoded, before copy and paste were, like, the vernacular, right? So this is kind of like going back to, like, oh man. Well, this is actually going right back to the 70s when, like VI would have been one of the first programs of this type that were created, So, yeah. All right. So, seems like an error, but it might not be. Actually, that's probably faster, double capital Z. Yeah? So these are your commands to write the changes that you've made to the file and exit the editor. W writes to the contents of the work buffer, of the working buffer to the file. Q quits. Q exclamation point, quits without saving. WQ, save and quit. W file name, specifying file name, allows you to save the file to a different file name. Your save as, if you will. Some resources. Cheat sheets. If any of you are going to start using VI, I highly recommend using a cheat sheet. At least until you're used to it. It's like, you know, I don't know. It's probably not for me because, like, I'm like one of those guys that doesn't even like use the hotkeys in like the strategy games he plays, you know. But yeah. All right. Let's see here. We technically still have 15 minutes left in class, and we are a little bit behind on class, so we should probably use that. So let's keep going, shall we? Yes.
Before that, could you open a week free?
Sorry.
Could you open a week free lecture? It wasn't on
My what free? What?
week free. Like the lecture.
Oh, week 3. Oh, I'm sorry. Yes. Boop. And you know what? Boop. I'll give you that one too. There's a freebie for you.
The resources are invisible.
Interesting. Boop, boop, boop. There we go. I don't know why that would be the case. The only thing you shouldn't see is the lesson plan, although the lesson plan is really not interesting anyway. You guys want to see the lesson plan? This is it. Yeah? There you go. There we go. We covered the VI slides. There you go. So let's talk about VS Code with GitHub Copilot. I'll grit my teeth and get through stuff about AI. Yes?
I don't want to delay it too much, but one of the main things that was missed on the slides for VI was a visual mode, which is for like selecting text and copying it and stuff like that.
Visual mode, eh? Okay. All right, let's see here.
So if you hit V, it enters into visual mode,
Visual, okay.
and then you can go up, and then if you hit Y, it'll copy any text you have highlighted.
Oh, that's easier and more intuitive for beginners than counting out lines. Yeah, okay.
And you can do like Shift V, and it'll select the entire line, or you can do Control V and do it like a 2D selection sort of thing.
So, and then yank, and then insert, and jump. Command mode, paste, put. There you go. Cool. All right. Thank you for that. Should recommend that being added to the slides. You clearly should have been consulted. You know. So. So there are 42 slides in this slide deck. We're not going to make it through them all, but we should make a start on them. All right. So Visual Studio Code with GitHub Copilot. Visual Studio Code is a text editor. The end. Available for Mac, Windows, and Linux since 2015. It's extremely popular. Previous popular editors like Sublime Text and Atom have dropped in popularity or have even been discontinued, as in the case of Atom. So at the moment, if you're only going to use one editor, VS Code is a good one. Unless you have a problem with stinky Microsoft. You can download it here. It's installed on the Mint image already, and I'm sure you guys know how to get it. There's an in-browser version of VS Code as well, which you may not have known about. There you go. Ta-da! There you go. Kind of suggests to me that, like, you know. Anyway, so. Activity bar, your sidebar, including your directory of all of the things that you have, right? Editor panes, that's where you edit your files. I'm explaining this to, like, how many people have used VS Code before? How many people have not used VS Code before? How many people know how to edit a file in VS Code? Moving on. Did you know that there's a status bar down there? It shows status. I'm sorry, I'll try to be more serious. So, Visual Studio Code comes with standard features such as syntax highlighting, bracket matching, code folding, and code completion via IntelliSense. So, do you guys know what code folding is? That might be the one thing that on this list that you don't necessarily know. Does anybody not know what code folding is?
Is that the thing where you can extend and close it?
Yeah, it's literally like you defined like a method or a function.
Yeah.
You get a little plus minus on the
Yeah.
side and you can like, yeah. Code folding. Man, maybe we will get through all of this in 10 minutes. VS Code Explorer. Notice the activity bar, which by default will be on the left. Yes. We can open files individually in Visual Studio Code. Yes. Or we can open folder. Yes. How many people didn't know that you can open a folder instead of a single file and therefore open the folder in the side pane? Did you guys know that?
Yep.
Okay. Good. Did you know you can run a terminal in it? Good. All right, how many people didn't know that? All right, we'll show it. Get out of here, VI. VS Code. There we go. Bing. Terminal, new terminal. There we go. Hey, it's even the right terminal. I don't know, maybe in Windows it would give you stinky PowerShell. Maybe. Does it?
Yeah.
Aw, stinky Microsoft trying to force their stuff on us. All right. Echo bash is cool. There you go. So you can get a terminal right there. Maybe it'd be possible to configure it if you have Windows Subsystem for Linux installed. Maybe you could force that to be a bash prompt. In Windows, it'll default to PowerShell. So, yep. We can configure basically it. Yep. Yep. Tab size, except tab size, yes. Note that VS Code will store your settings in a JSON format, okay? So if you want, you can modify its configuration settings manually, although this is theoretically the purpose of the GUI is to allow you to modify its configuration settings. You can grep it though, you can't grep it in a GUI. So let's do that. Get out of here, VS Code. CD dot config, was it config? See here, yeah, cd dot config with a lowercase, C for code, and was it settings? Forget, C, user. And settings.json. Wait, no, where is it? Yeah, there it is, settings.json. Grep settings.json tab size. No such file or directory. Oh, I got it reversed. Yeah. Doesn't exist. How about just tab? Cat settings.json. Well, that would be the reason I couldn't find it. Grep color. There you go. I grepped out all of the color options, which was the only option in the file. Very good. So, let's play around with some basic VS Code features. Extensions. How many people didn't know that VS Code has extensions? Okay. Extensions are powerful. Yes. An integrated development environment combines a text editor with other tools like debuggers, testing, etc. to ideally improve productivity and user experience. So, a regex previewer, all right? You guys, we covered regular expressions last time, yeah? So, regex previewer by Christoph Marty, just so that we know. Christoph Smarty. Yeah, there you go. You're a smart guy, Christoph Marty. It is this one, extensions. Regex previewer. There's my man, Christoph. There we go. Install. There we go. You guys knew you could do this, right? Yeah. And now we have that extension. I think this week's. I'll say it off camera. All right. We can make regular expressions and see which strings would match versus not match. Okay. Yes. Pull a tab to left side. Create a second editor group. All right. Okay. Now let's just go home. Thank you very much for your time and attention, folks. That's it. That's all she wrote. Let's go home. We'll pick this up next week. Safe drive, if you're driving. Safe walk if you're walking. Safe scoot if you're scootering.